All right, so let's take a look at this. Okay, so again, if you're kind of looking at how this is done, step 1, enter equation in the y editor. Okay, so if we take our equation and enter it just as it appears, so negative x to the 4th minus 2x cubed plus 3x squared plus 3x plus 4. All right, now, it's a good idea, just make sure before you start your work that what it appears when it's written up in the display is what you intended it to look like. And so if we looked at this, we could confirm all of the terms are correct. Okay. And now, if we're going through these to look, the left and right behavior. Now, do you need the graph in order to identify what the left and right behavior looks like? You shouldn't, because it's an even function with a negative coefficient. So you know that the left and right behavior will be the same. It's either both up or both down. Because it's a negative, it's going to be both down. The graph confirms it, but your answer would be down to the left, down to the right.
Wait, how do we know if they're both the same?
One of the patterns, anything that has an x to the odd power is going to look like this. A negative x to the odd power is going to be, again, you don't know how many times it changes directions, but you know the left and right behavior will look like this. Okay, anything with x to the even power is going to be, again, you don't know what happens in the middle. A negative x to the even power is going to open up down in both directions. So that's anything, whether it's a power of 1, 3, 5, 7, whether it's a power of 2, 4, 6, 8, whatever it happens to be, it'll fit that pattern. Now again, you have the use of your calculator, though, will confirm that. Right? Unless you've typed the expression or the function in incorrectly, there's no reason to miss those questions on your quiz or test. Okay. We can also answer the next question without having to look at the calculator at all. Where is the y-intercept going to be? 0, 4. It's x-coordinate 0. The y-coordinate is just whatever your constant is. So here's our constant plus 4. So that's what our y-intercept is. And again, you can confirm that on your calculator just by hitting the Math tab, choosing value, and it should be the default value. The default value is x is 0, so 0, 4 confirms that that's our y-intercept. Right, now, when you look at your x-intercepts, right, there's fewer ways to solve for the x-intercepts on this versus the factored form that we looked at yesterday. And remember, on the factored form, you could just take your factors, set them equal to 0, and those are your x-intercepts. In this particular case, we can't do that. We don't have factors. So we can do a couple different things. You can find your intercepts on your graph, but there's an easier way to do this. And how can you find your x-intercepts in the most efficient way? Solve, yeah. So if you go to your home screen, so you just hit the home button, and you use the solve feature, and you take your actual function. So instead of rewriting this, it's stored as our y1 equation. So we can just say y1 of x, set that equal to 0, and solve for x. That command will take the function that you've already typed in as the y1 function, set it equal to 0, and solve for x. And so when you do this, you get your solutions. Okay, so our x-intercept, one is negative 2.85. Again, probably have it rounded to the nearest 2 decimals. Okay, we can keep moving over. 1.68. Now, how many zeros would you expect from this? 4. How many zeros did you get? 2. So what's going on? How come? So what? Yeah, so it's either imaginary zeros or these are duplicated factors or zeros. So if I were to ask you to find all of the zeros for this function, again, just as a review, if you used csolve on this, you'd be able to see, are there any imaginary complex solutions other than the reals? And in this case, you do have two imaginary solutions. Okay. Again, I'm not going to ask you for these on your graphs. I'm just doing this as a review from the 6.7 material. Okay. All right, so we found both of all the x and y intercepts. So the last thing we need to do is view the graph and identify our relative minimums and relative maximums. Okay, so how many relative maximums do we have? We have two, right? Anytime it changes from what's increasing to decreasing and starts to change directions, that's a maximum if it's the highest point, a minimum down here if it's the lowest point, and another maximum. So let's go ahead and find the minimum first since it's just one. So if we're finding the minimum, we can go to the F5 Math tab, choose number 3, minimum. Now our lower bound has to be to the left of what we see our minimum is. Our minimum is somewhere between 0 and -1. So if we pick anything to the left of -1, but we can't go beyond what appears to be about a little before -3, because then that starts to drop below it again. So if we pick -1 or -2, we're pretty safe here. So I'm going to choose -2. And then my upper limit, or my upper bound, has to be to the right of this point, but again, somewhere where it doesn't start, the graph does not fall below that y-coordinate. So I can pick 0 or 1. Either of those will work. So I'm just going to choose 1 as my upper bound. And that gives me this lowest point. So that lowest point is the coordinate -0.39 if I round it to 2 decimals, and 3.38, again rounding to 2 decimals. All right, the final step then is to find your two relative maximum points. When I ask you for these on the quiz or test, I will specify the maximum furthest to the left and furthest to the right. And that involves on the graph. So here's the maximum that's furthest to the left on this graph. So if we go to the Math tab F5, choose maximum now. You have to do this separately. It's not going to, if you put from -10 to +10, it doesn't identify each of those individually. You have to do each one separately. So for this maximum, the one furthest to the left, I can pick any x-coordinate to the left of what appears to be just over -3. So if I pick anything below -3, I'm good. So I'm just going to choose a -5. Okay. And then for my upper bound, again, I'm finding the highest point. Is there any other point that's higher than this relative maximum? No. So really, I can pick any point. So in this particular case, I can find this one by going -10 to +10. It'll pick that highest point. Okay. I'm just going to pick 0 for my upper bound because I know it falls between those two. And it gives me my relative maximum, -2.05. and 10.03 approximately if I'm rounding to 2 decimals. And then my other relative maximum is right here. It's right around an x-coordinate of 1. So if I pick F5 Math tab, choose maximum, pick a point that's to the left. Well, 0, or where my cursor is already to the left of this, so I'm going to hit enter. My upper bound needs to be any x-coordinate to the right of this. So again, exaggerate it, so choose 2 or 3 at the very least, so I picked 3. And my relative maximum in that set is 0.94 and 7.03.